Hi guys, I'm going to give you a computer demonstration of how to do the two-way ANOVA assignment. So in the GitHub repository for the assignment, if you haven't, you want to fork this assignment to go to your own repository, and once you do that, you can download the files for this assignment and open up the zip file and extract it. In Windows, you're going to use extract all. Make sure the show extracted files when complete option is checked, and extract that. And then we can open the folder and open the answer sheet with instructions. And as always, there's three main sections to this instruction sheet. There's study information, there is dataset information, and there is test information. This is not an actual study, but I keep this here to remind you that if this were an actual study, these are things you should look at before you analyze any data. And not much up here other than research questions for the study. You can look in the field text, chapter 14.3 for a description of the study and what he was looking at in this made-up example. So we're going to go to look at the variables in this data set, and the data set is called goggles.sav, and we're going to open up Jamovi. We'll go to the File menu, Open, Browse. I know this is in my Downloads folder, and we'll go to the two-way ANOVA folder and open the goggles.sav file. And so we see we have a variable called face type with attractive and unattractive, and a variable called alcohol, which has groups placebo, low dose, and high dose, and an attractiveness rating. I do remind you that normally on a 10-point scale, I would normally call that an ordinal level of measurement, but Field has used this as a continuous variable, so you'll want to mark this as a continuous variable in the data set so we can make sure that these are set correctly in Jamovi. So we can double click on the column header. We see face type is listed as nominal with 2 levels. That's good. We can go to alcohol, also listed as nominal with 3 levels. And recall that categorical variables in ANOVA are often called factors. So this is our face type factor and our alcohol factor. And if we look at attractiveness, this is set as continuous, and that will be correct for this example. We'll go ahead and look at the StatCat option. So if we go to StatCat, Analyses, StatCat, and Relationships Prediction and Group Comparisons, we have face type is an independent variable, alcohol is an independent variable, and attractiveness is our continuous dependent variable. And StatCat, when it sees this, I would recommend a two-way ANOVA. So again, if you're not sure what kind of test you can do, have some variables that are the same level of measurement of what you're going to be doing, and you can put that in StatCat and get an idea of what types of tests are allowable given the variables you have. And StatCat does give you some nice little dot plots here with the variables that we're looking at. So always handy. And as usual, before we do anything, we're going to go do some descriptive statistics to make sure our data are clean. We did take a look. You can take a quick look. This isn't a very big data set, and see we don't have any missing data, and things looked okay as far as no misspelled categories or anything like that. But we always do get our descriptives, so we'll go to Analysis, Exploration, Descriptives, and I'm going to look at attractiveness and split up by groups. So I'm actually going to look at attractiveness split by face type, and attractiveness is a continuous variable, so we're going to keep our mean and standard deviation. I'll add skewness, kurtosis, and a Shapiro-Wilk test. And for continuous variables, we do get histograms and box plots. If we take a look at this, we look at our two different groups. We have no missing data. You see we have some mean differences in attractiveness. We got standard deviations there. Skewness, negative 0.2 and 0.42 and 0.2 and 0.42. So my skewness divided by standard error of the skewness is not greater than 2 for either of those. I don't anticipate that I have any issues with normality assumption. And I do remind you that you'll see that in these groups the Shapiro-Wilk is actually significant, and the Shapiro-Wilk test does take kurtosis into account, so sometimes things may be significant on your normality test, meaning that one is significantly different from normal, but the kurtosis may be what's driving some of that, and it's not going to be too big a deal because we looked at skewness and it looked okay, so I wouldn't worry about that one too much. And then we do have some plots of unattractive and attractive on the face type and some box plots. Let's go ahead and look at go to Analysis, Exploration, Descriptives again, and let's get attractiveness split by alcohol this time. We'll keep our mean and standard deviation and go ahead and get skewness and kurtosis in our normality test, and again histogram and box plot. And if we take a quick peek, again we don't have any missing data here. We have our three groups with 16 in each, means and standard deviations, skewness. We have negative 0.5, 0.5, negative 0.2, 0.5, and 0.18, 0.5. So again, I don't see any skewness where the skewness divided by the standard error, the skewness is greater than 2 in any of those, so I don't really anticipate any normality issues here. And we do see again this high dose is significant, but that's probably because of a combination of skewness and kurtosis, which again the kurtosis is not quite as important as the skewness, so I don't really see that we have any big problems here. No outliers, no missing data, so things look okay for that. So we are going to let's see if I've glossed over anything in the instruction sheet. So we did look at our variables, didn't see any issues there, nothing with missing data. So we're going to we did do our StatCat here as described in the instruction sheet, so we're okay with that. So assumptions for ANOVA, again this is based on linear models, so field refers you to chapter 6, and then learning statistics with Jamovi has a section about two-way ANOVA and assumptions, chapter 14, section 4. Outcome variables continuous. We want to look at our additivity and linearity, and we didn't see any real issues with that in those plots normally distributed sampling distribution. With large samples, you're usually okay because of the central limit theorem. With smaller samples, you will kind of look at the normality of the data, and we didn't see any significant problems with our normality for this example, so we're okay there. Homoscedasticity, when you have categorical variables, this is called homogeneity of variance, and we use Levene's test for that. We will take a peek at that when we run this test. Independence of observations, this is usually known by the study design, and we know that we're looking at different people in different groups and they're unrelated, and we're not looking at the same people at different time periods, so we know we meet that assumption. Predictor variables need to be categorical with 2 or more levels. They are. No extreme outliers. We didn't have any. So now we can go run our test. So to do that, talk about our null and alternative hypotheses. So in a two-way ANOVA, we have an additional independent variable that we didn't have before. So we will have a main effect for our first independent variable, we'll have a main effect for our second independent variable, and we have an additional effect called an interaction effect, which is is there a difference in the way these two variables behave for the different levels of the variables. So we're actually, we have a null and alternative hypothesis for each of those. The null hypothesis for our first main effect would be the same as it was for our one-way ANOVA, as if we were doing a one-way ANOVA with the first independent variable. The null is always some version of there is no difference, and so we will say there is no difference in the outcome variable between the different levels of the independent variable. And the alternative for the first main effect is there is a difference in that. And again, we're looking at our face type and our alcohol. So for the first one, we could look at face type. They're going to say there is no difference between the face type groups, attractive and unattractive. And the alternative is there is a difference for our second main effect, it's alcohol. We would say there is no difference in our alcohol groups in our attractiveness rating. And the alternative would be there is a difference. And then the interaction, the null is there is no interaction effect, and the alternative is there is an interaction effect. So those would be all null and alternative hypotheses for those three effects that we're concerned about. Again, our criteria for rejection we're using for these examples is alpha equal 0.05. That's not going to change. What is the advantage of conducting a two-way ANOVA instead of conducting two one-way ANOVA tests? And this is very similar to why would you do an ANOVA as opposed to multiple independent t-tests to look at group differences. And the main reason is it cuts down on the number of tests that you're conducting. And the other difference here is that the two-way ANOVA allows us to test for an interaction effect, which we would not get if we conducted two one-way ANOVAs. So the focus of a two-way ANOVA really comes down to this interaction. Is there an interaction going on? And what that means is that the outcome variable is different based on the different groups in the independent variables. The groups behave differently from each other. So that's really going to end up what we focus on. So that's the main advantage of a two-way ANOVA over multiple one-way ANOVAs, is we do get this interaction effect. And Field and Navarro recommend using an omega squared as their effect size, so we will select that when we do this. So we're going to calculate this test statistic. We looked at this menu last time. We're going to have Jamovi, Analyses, ANOVA, ANOVA. So we'll go to Analyses, ANOVA, ANOVA. And Our dependent variable is our attractiveness rating, our fixed factor, our face type, and alcohol. Our effect size, we're going to select omega squared, and assumption checks, we'll go ahead and get all of our assumption checks. Post hoc tests, let's go ahead and get post hocs. We'll do a 2-key with a Cohen's D for those. And I do describe in here, we're going to look at some of these values and Levine's test. But really what we end up caring a lot about are these interaction effects. And that's often easiest to understand by getting a plot for this interaction effect. So we're going to do that. And I describe what we're going to do here. We're going to look in the estimated marginal means drop down, and we're going to create two plots, one plot which puts face type first in the interaction, and one plot which puts alcohol first in the interaction. So for the first one, we'll go to the estimated marginal means drop down, select facility type and move it to the term 1 section in the marginal means, and then select alcohol and move it to the term 1 section. So let's go take a look at that. Estimated marginal means, face type, and alcohol. And we've got marginal mean selected, and let's just make sure we're getting that. All right, that's good. We've got those going right there. Okay, so then I added a new term and I did them in the opposite order. And the reason I do this, I usually will do this both ways because sometimes one plot ends up being easier to interpret than the other. And I like this one that has alcohol first and face type second, because this looks easier to interpret to me. So we're going to talk about that in just a second. Just make sure we didn't miss any options in here. Okay, so we're going to go look at these, and when we look at the output for a two-way ANOVA, the first thing we always look at is the interaction. And so you can see that here's our different, here's our ANOVA table, here's our main effective face time, main effective alcohol, and then you'll see the face type asterisk alcohol, that's the interaction effect. And we can see here's our F statistics for each of those and our P values. So the first thing we always look at for a two-way ANOVA is the interaction. And if that is significant, that is where we really put our focus for the rest of our analysis. If that were not significant, then we would look at each of the main effects of the independent variables on its own, as if we were just doing a one-way ANOVA with it. So we do see that they're all three significant. There's our F values for all three. You will see that we have our degrees of freedom for each of our main effects and our interaction and residuals right there. And we do have an omega squared for these, and I believe our omega squared values were 0.01 to 0.06 were small, 0.06 to 0.14 was medium, and then above 0.14 was large. So we do have some pretty large effects on all of these. Homogeneity of variance, we see that our p-value is not significant, so we pass our homogeneity of variance assumption, and that means we pass Levine's test. The variance in the different groups is not significantly different from each other, and we can see our overall Shapiro-Wilk test is not significant. In our QQ plot, the dots are pretty much along the line, meaning that these residuals follow pretty much a normal distribution. So again, we look pretty good with all of our assumptions. And rather than look at post hoc tests, we're going to go first and look at the interactions. And again, we could tease out this one with different lines are the alcohol groups, and our phase type is our different categories on the x-axis, but I'm going to go down and use this one that has 2 lines for phase type and 3 spots for placebo. So what you can see here is if there was no interaction, these lines would be parallel to each other. And what we see is these lines actually cross each other up here. So we can see that there's quite a bit of separation here between the attractive, which is the blue line, and the unattractive was the blue line, and the attractive is the yellow line. And down here at the placebo group, the low dose group, again, they're not really parallel, but they don't cross. But there is quite a difference in the slope there. That would probably give us a significant interaction. And then here between low dose and high dose, we see that they actually switch places. And with alcohol, attractiveness goes up. With high dose alcohol, attractiveness goes up quite a bit, and unattractiveness goes up quite a bit, and attractiveness comes down for that high dose group. So we see that this is not significant. And if we were writing up results for this, we pretty much would report that we had a significant interaction, and then we would describe this pattern. You could even include the plot in your results because it really kind of shows what's going on. So these two-way ANOVAs can get complicated to interpret. You can have ANOVAs with more than 2 factors in them, and they get really complicated really fast, because what you'll end up having is a 2-way interaction for each pairwise combination of the independent variables, and then you'll also have a 3-way interaction. So by adding one more independent variable, you'll go to 4 interactions that you're looking at, and they get very complicated to interpret. In actual practice, I think in my time, when I was reading a lot more research, I only actually came across one published study that had a 3-way ANOVA, and they just get so complicated to interpret that they often are of limited utility. So 2-way is probably the most you're going to see commonly, and as you can see, it is a little more complicated to interpret this, but we can see that unattractive face ratings, the attractiveness ratings go higher as alcohol goes higher, and attractive face ratings don't change a lot with the different alcohol levels, and that's basically what I would describe in this pattern. So we can save this Jamovi file, so we'll go to File, Save As, Browse to make sure we're in the right folder, and we're here in our 2-way ANOVA folder, and I'm just going to save that. And we can save our output by right-clicking in the output window, go to All, Export, Browse, make sure that we're in the right folder. We are, and we could say goggles output, save as a PDF, and we can go ahead and close that. We can so we talked about those interactions. Field does tell you how to report these in chapter 14 section 11. You don't have to write that here, but it is good to start learning how to do that. And then we can go look at our R file, or R markdown, or R notebook, and our .rmd file, and we're going to open with RStudio, hit OK. And go ahead and run these code blocks as we have before. You shouldn't have anything new to install here. We're not using any new packages, but as I've noted in prior videos, if you have not run these before, this install step can take a good bit of time to install all the packages needed. Be patient, give it time to run. But since we've been running these all semester, there isn't anything new to install. This is talking about ANOVA as a linear model, and we're going to open this up, and I will, rather than use the file chooser that's displayed here, I'm just going to change this to the name of the variable. Remember to put that in quotes, and run that if we're set up in the right folder, which it is when we open it this way. We do get our data set here with our different variables, so that looks like that imported properly. You can pull R code from Jamovi, and I talk about how to do that here. We're not going to pull anything. We are going to look at some histograms and for our different variables. There are different groups like we looked at before, and we're going to switch our variables, our independent variables, to factors to get some box plots for them. And we do have box plots there. And I talk a little bit about dummy coding here. If we do have a categorical variable that has more than two groups, then you're going to do dummy coding. If you get ambitious, you can go try this in Jamovi. They actually make it pretty simple. They do the dummy coding for you. But I did go through and calculate this with an interaction and these variables, and we can see some of what comes out there, and you can compare that to what Jamovi gives us using Jamovi output. So just some more exposure to how you might code some of these things in R directly, not using Jamovi. And we can go knit this to a markdown document. And we can see our files are getting added over here. Takes a minute to run, be patient. All right. Don't care about saving the workspace. And you'll see there's our new markdown document. There's our Jamovi file, and we should have our PDF in there somewhere. I might have forgot to save the PDF, but go back and save it if you didn't save it. And you can go to your repository, add file, upload files, and you can drag your files into your repository. You're going to click on commit changes, but I am not going to do that because I don't want to add those to this assignment repository. And that is how to complete this assignment. So if you have questions, post them in the discussion or come to office hours, and have a good day.